Hello friends, welcome to our channel, Gajpal A Learnag. In today's video we are going to study about the new topic. That is non-aqueous titration. Solvents used in non-aqueous titration and indicators for non-aqueous titration. So let's start. First, non-aqueous titration. Non-aqueous titration, also known as non-aqueous titration or solvent titration, is a type of chemical titration that involves the use of a solvent other than water as the medium in which the reaction takes place. In traditional acid-base titrations, water is typically used as the solvent, but in non-aqueous titrations, organic solvents or other non-aqueous substances are employed. Non-aqueous titrations are commonly used in analytical chemistry for several purposes, including: first, determination of acidic or basic substances. Non-aqueous titrations are often used to determine the concentration of acids or bases that are insoluble or react slowly in water. Organic solvents, such as acetone or ethanol, are frequently used as the titration medium. Second, analysis of organic compounds. Non-aqueous titrations are particularly useful for analyzing organic compounds that are sensitive to water or that may undergo side reactions in an aqueous medium. Third, electrochemical measurements. Some non-aqueous solvents can be used in conjunction with electrochemical techniques, such as coulometry or potentiometry, to determine the concentration of specific ions or substances. Points to note: common titration reactions in non-aqueous titrations include acid-base reactions, redox reactions, and complexometric titrations. The choice of solvent depends on the specific chemical properties of the substances being titrated and the desired experimental conditions. Non-aqueous titrations require careful selection of solvents, indicators, and techniques to ensure accurate and reliable results. They are particularly valuable in situations where water cannot be used, and they provide analytical chemists with a versatile tool for a wide range of applications. Next is solvents used in non-aqueous titrations. Non-aqueous titrations use a variety of organic solvents or non-aqueous substances as the medium in which the titration reactions take place. The choice of solvent depends on the specific titration reaction and the properties of the substances being analyzed. Here are some common solvents used in non-aqueous titrations, along with descriptions of their characteristics. First, acetone, CH3COCH3. Acetone is a widely used solvent in non-aqueous titrations due to its high polarity and ability to dissolve a wide range of organic and inorganic compounds. It is often used for titrations involving strong bases or acids. Second, methanol, CH3OH. Methanol is a polar solvent that is frequently used in non-aqueous titrations. It is suitable for titrations involving both acids and bases and is often chosen when the analyte or titrant is sensitive to water. Third, ethanol, C2H5OH. Ethanol is another polar solvent commonly used in non-aqueous titrations. It is often chosen for its compatibility with a wide range of organic compounds and its ability to dissolve both acidic and basic substances. Fourth, dimethyl sulfoxide, DMSO. DMSO is a highly polar and aprotic solvent that is useful in non-aqueous titrations when water would interfere with the reaction. It is particularly suited for reactions involving highly polar or ionic compounds. Fifth, toluene, C7H8. Toluene is a nonpolar solvent and is sometimes used in non-aqueous titrations when dealing with nonpolar or hydrophobic analytes. It is not suitable for acid-base titrations but may be used in redox or complexometric titrations. Sixth, perchloric acid, HClO4. While technically an acidic solution, perchloric acid is often used as a titration solvent in non-aqueous titrations, especially in the determination of halides and other substances that can react with it in a non-aqueous environment. Seventh, carbon tetrachloride, CCl4. Carbon tetrachloride is a nonpolar solvent that can be used in specific non-aqueous titrations, particularly those involving organometalic compounds. It's important to note that carbon tetrachloride is toxic and volatile, so it should be handled with care. Eighth, nitromethane, CH3NO2. Nitromethane is another nonpolar solvent suitable for certain non-aqueous titrations, particularly those involving organic compounds. It can dissolve a wide range of substances and is often chosen when other solvents are not appropriate. Note: when selecting a solvent for non-aqueous titrations, it's crucial to consider the solubility of the analyte and titrant, as well as the chemical compatibility of the solvent with the substances being analyzed. Additionally, the choice of solvent may influence the selection of indicators and other experimental conditions to ensure accurate and reliable results. Proper safety precautions and handling procedures should always be followed when working with non-aqueous solvents, as some of them may pose health and safety risks. Next, indicators for non-aqueous titration. Indicators for non-aqueous titrations serve a similar purpose to those used in aqueous titrations. They signal the endpoint of the titration by undergoing a noticeable color change or other observable change. However, as mentioned earlier, the choice of indicator in non-aqueous titrations is critical because not all common aqueous indicators are suitable due to differences in solvent properties and chemical reactions. Here are some examples of indicators for non-aqueous titrations and the types of titrations they are typically used for. First, phenolphthalein. Phenolphthalein is a widely used indicator in non-aqueous titrations, especially in titrations involving strong bases. It changes from colorless to pink or magenta as the pH of the solution shifts from acidic to slightly basic. It's suitable for acid-base non-aqueous titrations in solvents like ethanol or acetone. Second, methyl orange. Methyl orange is another common indicator used in non-aqueous titrations, typically for titrations involving strong acids or bases. It changes color from red to yellow as the pH transitions from acidic to slightly basic. It's often used in titrations conducted in solvents like methanol. Third, bromethymol blue. Bromethymol blue is an indicator that can be used in non-aqueous titrations, primarily for acid-base titrations. It changes from yellow to blue as the pH of the solution increases from acidic to slightly basic. It's suitable for titrations in solvents like acetone or methanol. Fourth, areochrome black tea. Areochrome black tea is a complexometric indicator used in non-aqueous titrations for the determination of metal ions, particularly those involving the formation of metal ligand complexes. It undergoes color changes from wine red to blue or purple as metal ions are complexed. It's often used in titrations with solvents like acetic acid or ethanol. Fifth, Ferroin. Ferroin is a redox indicator used in redox titrations conducted in non-aqueous solvents. It changes from pale blue to reddish-brown as the redox potential of the solution reaches a specific value. It's commonly used in titrations involving ions and other transition metals. Sixth, diphenylamine sulfonate, DPS. DPS is a redox indicator used in certain redox titrations in non-aqueous solvents. It changes color as it undergoes a redox reaction, which can be used to signal the endpoint of the titration in specific cases. Seventh, calmaget. Calmaget is a complexometric indicator used in non-aqueous titrations, particularly those involving the determination of calcium ions in organic solvents. It undergoes a color change from red to blue as calcium ions are complexed. 8. Thymolphthalein. Thymolphthalein is an indicator that can be used in non-aqueous titrations, particularly for titrations involving strong bases. It changes from colorless to blue as the pH of the solution shifts from acidic to slightly basic. Thymolphthalein is often used in non-aqueous solvents like ethanol. 9th. Xylnol orange. Xylnol orange is a complexometric indicator used in non-aqueous titrations, primarily for the determination of metal ions that form stable complexes. It changes color from yellow to red as metal ions are complexed. This indicator is suitable for titrations conducted in solvents like acetone or acetonitrile. 10th. Indigo carmine. Indigo carmine is a redox indicator used in certain redox titrations carried out in non-aqueous solvents. It changes color as it undergoes a redox reaction and can be used to signal the endpoint of the titration in specific cases, particularly those involving organic substances. Thanks for watching this video. If this video was helpful, then please kindly subscribe the channel. Thanks you.